occurs when a large star, a single star and not a double star, is in the process of dying. A type 2 supernova occurs only in a star that is truly massive, a star that is at least 10 times as massive as our Sun. A supernova occurs in this type of massive star only when it is very old. The core of such a massive star in its very late stages of life becomes progressively hotter and hotter until the core collapses and a whole series of thermonuclear reactions occur, causing a supernova. Probably the most famous and brightest historical Type 2 supernova occurred in 1054, near the beginning of the last millennium. It was recorded in China, and Chinese records indicate that it was visible to the naked eye even during daylight for 23 days, and was visible to the naked eye at night for 653 days, or almost 2 years. The Chinese also recorded 2 other supernovae in 1006 and 1181, though these were not as bright as the 1054 supernova. From then, it was not until 1987 that another Type 2 supernova was visible to the naked eye. In 1987, a Type 2 supernova occurred in a galaxy close to the Milky Way, our galaxy. This was the only supernova that was strong enough and close enough to Earth to be seen from Earth without a telescope in over 400 years, since the 2 Type 1 supernovae were observed in 1572 and 1604. The 1987 supernova was the only Type 2 supernova to be visible to the naked eye in close to 1,000 years.
Thanks for coming in, Beth.
You wanted to see me? Is there some sort of problem?
Well, not exactly a problem, but there is something we need to discuss. I asked you to come here because I want to talk with you about your schedule. I mean about the courses you've already taken and the courses you've signed up to take next year.
Is there something wrong?
It's not exactly wrong, but it's something we need to deal with. Let me lay it out for you. Here it is. You've declared that your major is sociology?
Yes, that's right.
But you haven't been taking too many sociology courses.
No, I guess I haven't.
There are some required courses for a sociology major that you should have taken, but you haven't. If you want to graduate on time with a degree in sociology, then you're behind. You haven't taken some courses that you should have taken by now.
I guess I understand that. I mean, I know I haven't taken some courses I need for a sociology major, but let me tell you what I've done and why. When the new schedule of classes comes out each semester, I like to sign up for courses that seem interesting to me. So I take a whole bunch of really interesting classes, and I don't seem to sign up for the required classes, particularly the ones I need for a sociology major.
Well, if you aren't really interested in the courses that are required for sociology, maybe you're not in the right major.
I think I was coming to that conclusion. Each time the class schedule comes out, the courses that are offered in sociology don't seem very interesting to me.
Is there some other major that interests you? Have you thought about that?
Well, you can see from the list of courses I've already taken that I'm not very interested in a single subject. I seem to enjoy courses in a bunch of different areas.
Well then, I have something to suggest to you. There's a major in general studies at this university. To get a degree in general studies, you need to take courses from 4 different departments, so you need to take a wide variety of courses.
That sounds like it might be the best thing for me.
Let me give you some information about the general studies degree, and you can look it over and see what you think.
I'll do that.
And then come back to see me after you've made a decision about it.
I'll do that too.
I hope you're ready to discuss the chapter on carbon in our chemistry text. We're going to be having a quiz on this chapter later today.
I think the main point of the chapter is that carbon is unique because of how many compounds it can form. I believe the chapter said There are more than 7 million compounds that contain carbon.
Yeah, that's right. More than 7 million carbon compounds are now known, and there are only 100,000 compounds made from all the other elements. That's because the carbon atom attaches easily with other carbon atoms and with many other kinds of atoms.
I think that we need to become familiar with some of the better known carbon compounds. The chapter discusses a few of them. I remember that it discusses graphite and gasoline and some others.
It discusses graphite and gasoline, as well as soap and diamonds.
Hey, graphite and gasoline seem like they're made from carbon, but it really seems strange that soap and diamonds are also derived from carbon. Let's look at graphite first. What does the chapter say about graphite?
Graphite is made only of carbon. Look at the diagram of a graphite molecule in the text. It has rings of 6 carbon atoms each, and 2 of the carbon atoms are part of each ring.
Isn't graphite what's found in pencils?
Yes, graphite is the primary component of the lead in pencils.
The next carbon compound is gasoline. Look at the gasoline molecule in the book. The carbon atoms in this molecule are in a chain rather than in rings, as they were in the graphite molecule.
And unlike the graphite molecule, which was made only of carbon, the gasoline molecule is a compound of carbon and hydrogen.
This gasoline molecule is a molecule of octane because it contains a chain of 8 carbon atoms, and octane means 8. The chapter says that different types of gasoline molecules each contain a chain of between 5 and 10 carbon atoms.
Now on to the soap molecule. I really didn't know that soap contained carbon.
Yeah, it does seem strange to think that soap contains carbon, but it does. Now, what about the soap molecule?
There doesn't seem to be a picture of a soap molecule in the text. Oh, but the text does say that the soap molecule has a long chain of carbon atoms, a much longer chain than the gasoline atom.
The text says that soap atoms can have anywhere between 5 and 7 carbon atoms in a chain.
Are you sure it says 5 to 7? It's supposed to be a long chain of carbon atoms, and 5 to 7 doesn't seem right.
Oh, here it is. Excuse me. You really do seem to have a good grasp of the material. The book doesn't say 5 to 7, it says 15 to 17.
Let me get this straight. A soap molecule has 15 to 17 carbon atoms in a chain, not 5 to 7.
You got it.
Sorry for the confusion.
It's okay. All right, now that we understand this, that makes 3 of the types of carbon molecules we have to deal with. So there's only one more. The last example of a carbon molecule is diamond. Oh, here's the diagram of a diamond molecule.
This diamond molecule consists only of carbon, and the carbon atoms are arranged in a very complex pattern. Oh, that's what helps to make diamond harder than any other natural substance.
Okay, I think we got all the necessary information on carbon and a few of the many compounds that are formed from it. In graphite, the carbon was in rings, while in octane and soap, it was in long chains. And in diamond, it was in a very complex pattern.
And graphite and diamond molecules are formed solely from carbon, while gasoline and soap are compounds of carbon atoms and other types of atoms.
I think we're ready for the quiz today. See you at our next study session, the day after tomorrow.
The text says that soap atoms can have anywhere between 5 and 7 carbon atoms in a chain.
There is
There are several common misconceptions about somnambulism, or sleepwalking, and I'd like to talk about two of them now. One common misconception about sleepwalking is that someone who is sleepwalking should not be awakened. Many people will say that it's dangerous to awaken someone who's sleepwalking, but this is not true. It's not really dangerous to awaken someone who's sleepwalking. Another common misconception about sleepwalking is that someone who's sleepwalking can't get hurt. This is also not true. Someone who's sleepwalking can easily get hurt by running into something or by tripping and falling.
Hey, Tina, you took Dr. Hall's sociology class last year, didn't you?
Yes, I did.
And you liked it?
Not at first, but later on I did.
Really? I've just started his class, and I don't like it at all. What made you change your mind about it?
It wasn't that I changed my mind about it. It's that the class changed, and I liked it better later on. At first, I didn't understand very much of the class at all.
That's the problem I'm having now. How did the class change when you took it?
Well, it wasn't that the class changed on its own. We students caused the class to change.
How did you do that?
We started asking questions, asking a lot of questions. Do any of you ask any questions?
We can't. There's not any time to do that. Dr. Hall just charges on and on. He doesn't even seem to stop to take a breath.
I know what you mean. If no one asks any questions, he just assumes that everyone understands everything. For the first few weeks of my class, no one asked any questions, and he just moved so fast.
And how did you change that?
Well, after a couple of weeks, someone started asking questions, and Dr. Hall answered them. Pretty soon, we all figured out that we were supposed to ask questions, lots of questions, to keep him from going so fast.
But nobody asks any questions because he's going so fast.
You just need to start asking questions. At first, Dr. Hall will seem a bit surprised because nobody has asked any questions so far, but he'll answer your question and then ask another question.
And another after that.
Exactly. That's how you get him to slow down.
Type 1 supernova, the kind of supernova that you read about in the reading passage, is not the only kind of supernova.